So let's kind of summarize what we have studied till now in this particular lecture on closed loop control systems and the comparison between closed loop and open loop control systems. And let's look at what is the advantages and disadvantages of having feedback. What's the cost of feedback? So the advantages of having a feedback loop in a control system is, first of all, you have reduced system sensitivity to parameter changes. And we've seen that in terms of the parameter change, in terms of the changes to the steady state error, in terms of the changes to the transfer function as a whole. We've also seen that feedback control systems are very good at rejecting disturbance and rejecting measurement noise, right? Unlike in the open loop control system. Of course, what all this means, all this boils down to, is that feedback control systems are able to keep the output at the same level as compared to the input. Other advantages of feedback control system where we looked at was a much better control of the transient response as compared to in the open loop uh, systems. But what is the cost that you pay to get these advantages? The cost is, of course, an increase in number of components and complexity in the system. Putting a feedback increases the complexity of the system and probably increases the number of components in the system as well. When you put a feedback, you're basically sensing the output. So there is some noise added into the system because of the sensor. There is a loss of gain, which we looked at when we looked at the control system in the on Simulink. And one of the biggest things that happens with the introduction of feedback is that there is a possibility of instability. And what we'll do is we'll look at how we can prevent stability. First of all, how we can analyze when a feedback system becomes stable and how we can prevent stability.